Hi, welcome to my channel pibyme Maths. This is by WST02. Here we are solving January-February 2022 Statistics 2 paper. Let's look at question number 1. A local pottery makes cups. The number of faulty cups made by the pottery in a week follows a Pearson distribution with mean 6. It can be lambda depending on the question actually. In a randomly chosen week, okay, so we can take this as lambda. If the question talks about 2 weeks, then you multiply this by 2, right? The probability that there will be at least x faulty cups, okay, first of all, I'm going to put x follows Pearson distribution of 6. When they say at least x faulty cups, x is greater than or equal to x is given. The probability is given. We need to find the value of x. You can rewrite this as 1 minus p of x is less than x or less than or equal to x minus 1. So when you rearrange the equation, x is less than or equal to x minus 1 is 1 minus this value, which is 0.8472. So from the table, we are going to look for lambda is equal to 6. And the probability is this and the corresponding value of x. So let's go to the table. Okay, here. No, not this. Here. Lambda is 6. That's the second one. We need to look for the probability 8472 in second one. We have 8472 here. The corresponding value is 8, right? So we know from table x minus 1 is equal to 8, x is equal to 9. That's all. It's an easy 3-mark question. Let's move on to part B now. Use normal approximation to find the probability in a 6 randomly weeks. So in 1 week, lambda is 6. For 6 weeks, it's 36, right? So x follows Pearson distribution of 36 is same as y follows normal distribution of lambda comma lambda, where mu is 36, sigma is square root of 36. They want you to find the probability that total number of faulty cups is fewer than 32. They want us to find y is fewer than 32. First, always apply the continuity correction. So y is less than or equal to 31.5. You should know how to apply the continuity correction before applying the normal approximation. If you don't know, just go watch my video and learn that properly. Now standardize the normal distribution. Z is less than or equal to x minus mu over sigma. And then you should find the probability using the method, normal distribution method you learned in S1. 31.5 minus 36 over square root of 36 is equal to P of Z is less than or equal to minus 0.75, which is same as 1 minus Z is less than or equal to positive 75. Take the table value now. For 0.75, the table value is 7734. So 1 minus 0.7734, it's going to be 0.2266. That's all. Let's look at part C now. A week is called poor week if at least x faulty cups are made, where x is the value found in part A. In part A, we got x is equal to 9, right? So if P of x is at least 9, greater than or equal to 9, that means if they made 9 or more faulty cups, that particular week is called a poor week. And we know the probability of this here. For at least x, it's 0.1528. This probability is 0.1528. Find the probability that in randomly selected 50 weeks, more than 1 is a poor. More than 1 out of 50, it's a binomial. So n is equal to 50. So you can write m follows binomial distribution of 50, 0.1528. So they want us to calculate more than 1, which is same as less than or equal to 1. For questions like this, you have to be very careful. You need to find the n and the probability of success. Then apply the binomial distribution. And then one more thing, they would expect you to write this actually. P of m is 0 plus m is 1. Since it's a 4-mark question, you can't just take the calculator values actually. So 1 minus, now you can take the calculator values or apply the binomial distribution. NC 0, P power 0. P is this, so Q is 1 minus P, which is 0.8472. So 0.1528 to the power 0 times 0.8472 to the power 50 plus 50C1 times P power 1 times Q power 50 minus 1. Find this probability. Okay. The first one, 50C0 is 0, anything power 0 is 0. It's just 8.8472 to the power 50 plus 50C1 is just 50 times 0.1528 power 1 is the same times 0.8472 to the power 49 and subtract the value from 1. 99748, 0.99748 dot dot dot, round it to 3 significant figure, 997. That's all. Question number 2 now. We have a capital F of x cumulative distribution given. Specify fully in terms of k the probability density function. So first differentiate this. D over dx of capital F of x is x becomes 1, k becomes 0, you will get 1 over 4k. So you can straight away write f of x. F of x is equal to 1 over 4k or 0 otherwise. Here write the same limit as capital F of x. This is how you write f of x. Part B, I will write the working here. Part B, write down in terms of k the value of e of x. Look at the PDF. There is no x here, right? Just a constant. That means it's a uniform, continuous uniform distribution where there is a formula to find e of x. It's b plus a over 2. This is a, this is b. So you don't need to write the formula. It's there in the data booklet. So 3k minus k over 2 is just k. That's all. Part C and D. So I'm going to put f of x here. Part C, show that the variance of x is this. For variance of x also there is a formula, b minus a whole square over 12. So b minus of minus k whole square over 12, which is 4k square is 16k square over 12. So when you simplify this, you are going to get 4 4s are 16, 3 4s are 12. That's all. Let's do part D now. For part D, start with variance of x. The formula is e of x square minus e of x whole square. So put this thing here as make e of x square as a subject, which is variance of x. We just calculated variance of x plus e of x whole square. We calculated e of x as k in part B, right? So it's going to be plus k square is going to be 7k square over 3. But they want e of 3x square. E of 3x square is same as 3e of x whole square, which is 3 times 7k square over 3. 3 can be cancelled. You'll get 7k square. That's why they want the answer in terms of k. Question number 3 now. A photocopier in a school is known to break down at random at a mean rate of 8 times per week. given a reason why a Poisson distribution could be used. So whenever you get questions like this, you write the whatever the event, right, it's happening at a constant rate and they are independent of each other. So you can write give a reason why we assume the breakdowns are independent and occurring at a constant rate. Always write this. Part B now. The head teacher of the school replaces the photocopier with a refurbished one and wants to find out if the rate of the breakdown has increased or decreased. Write down the suitable null alternative hypothesis. Null hypothesis is P is equal to, they say 8 times, right? It's not P, it's Poisson distribution. So lambda is 8. Alternative hypothesis, lambda, they say increase or decrease, it's a two-tailed test, not equal to 8. Part C now. The refurbished photocopier was monitored for the first week after it was installed. Using 5% level of significance, find the critical region. We have H0, which is lambda is 8. H1, lambda is not equal to 8. And assume that H0 is true. So we can write X follows Poisson distribution of 8. Now since it's a two-tailed test, we need to divide the significant level by 2 first. 0.05 divided by 2. So we'll be using this one. And then we need to test both X is less than or equal to X is less than the half of the significant level, and X is greater than or equal to X is still less than the significant level, and we do that lower tail test, upper tail test to find the critical region. Okay, I'm gonna do the lower tail test first. I need to find all the X values that satisfy this condition for lambda is equal to 8. Okay, I have put the table values here. This is for the table values corresponding to lambda is 8 and the X values are 1, 2, 3, 4, 5, 6. I have taken some values because we are looking for the values that are smaller than this. This is smaller than 0.025, this also not this. So you need to write P of X is less than or equal to 2 is 0.0138 is less than half of the significant level. P of X is less than or equal to 3 is 0.0424 is greater than this. You need to show where it changes. Therefore, X is less than or equal to 2. That's just one part. That's not the final critical region. Now we need to do the upper tail test actually. X is greater than or equal to X is less than 0.025. Here the trick is take 1 minus of this and see where the value from the table switches from less than 975 to greater than 0.975. Okay, I'm going to put some table values here. The corresponding values of X are 11, 12, 13, 14, 15. Now the value switches from less than 975 to greater than 975 here. So I'm gonna take 13, but I'm gonna start writing it as 14 actually. Why I'm doing that? So when I rewrite it, X is less than 14 or less than or equal to 13, I can use the particular value. Is 0.0342 bigger than the significant level. And then to use the value of 14, I'm gonna start writing it as 15. So when I rewrite this, I can use the value of 14. 1 minus 0.9 is 27, which is 0.0172 is less than the significant level. Therefore, X is greater than or equal to 15. So we need the critical region. Therefore, the critical region is you need to combine these two. X is less than or equal to 12 or X is greater than or equal to 15. So that's the answer for part C. Part D now, find the actual significant level. So you need to take the probabilities corresponding to the critical values. So you need to take these two probabilities, the highlighted probabilities, and then add them, change it to a percentage. 138,172. So 0.0138 plus 0.0172. 0.0138 plus 0.0172. 0.031 times 100. That's 3.1 percentage. That's the actual significant level. Part E now. During the first week it was installed, there were 4 breakdown. 4 is the observed value. Comment on this finding in the light of the critical region. We know the critical region is X is less than or equal to 2 or X is greater than or equal to 15. The 4 does not lie in the critical region. 4 does not lie in the critical region. So if it lies in the critical region, we reject H naught. So we do not reject H naught. What does that mean? Here, go back to the question here. We accept this, we reject H1. That means even they use the refurbished photocopier, still the mean rate is 8. It is not changed. So you need to write it as a sentence here. You need to write finally, otherwise you will lose a mark. You cannot just write do not reject H naught. You need to write there is insufficient evidence to suggest that the refurbished photocopier has changed the mean number of breakdowns, mean rate of breakdowns. You have to write that, otherwise you will lose a mark. Question number 4. The continuous random variable has a PDF function this where k is a positive constant. Okay, you have k here, here and here. Sketch f of x. Okay, to sketch f of x, first sub in 1 here. So 1 minus 1, 0, you will get 0, right? So probably will show the working. F of 1 is 0. F of 3 is, when you sub in 3, you're going to get 2, 2 will be cancelled, you will get k. And then f of sub in 6, it's just k. Sub in 10, it becomes 0. F of 10 is 0. So I'm going to sketch the graph now. Draw the f of x and x-axis. Always label the axis on the origin first. Okay, from 1 to 3, when you put 1, it's 0. So this is 1, 0. And then when it's 3, it's k. It's a line goes all the way to k. This is k. And then 3 to 6, it's just k. 3 to 6, it's just k. And then I'm gonna extend this line. 6 to 10, when we put 10, it's 0, right? So it goes down again. That's a function. That's all you need to show. So you'll be given 2 marks for this. Part B, show that k is 1 over 6. I'm gonna put the diagram here. This is a PDF function. We know for sure the area below the PDF function is 1, right? So this is a trapezium. How do we find the area of the trapezium? Half times this length. From 6 to 3, it's 3 plus the bottom length 10 to 1 is 9 times the height is k, right? Is equal to 1. So k is 2 over 12 is 1 over 6. That's all. Just a 2 mark question. That's the easiest way to find k. Part C now. So I have copied the PDF function here. Specify fully the cumulative distribution function. So I'm going to integrate the function one by one. When I integrate this, I'm going to keep k over 2. K is 1 over 6. So 1 over 12 outside. X becomes x square over 2 minus x plus c. The lower limit is 1. So I can apply the condition f of 1 is 0. So 0 is 1 over 12 times half minus 1. That's minus half minus 1 over 24. So C is positive 1 over 24. So that's first f of x. 1 over 12 times x square over 2 minus x plus 1 over 24. And then I'm going to integrate this now. F of x is equal to kx plus c. Okay. Since 3 is a common limit, find 3 f of 3 here by subbing here. So f of 3 is 1 over 12, 3 square over 2 minus 3 plus 1 over 24 using the condition sub in here. So what's f of 3? 1 over 12 times 9 over 2 to minus 3 plus 1 over 24, 1 over 6. So f of 3 is 1 over 6. Using this condition in here, 1 over 6 is, replace x by 3, 3k. We know k is 1 over 6. So 3k is 1 over 2 plus c. c is 1 over 6 minus 1 over 2. That's minus 1 over 3. So we can write f of x as kx minus 1 over 3. You see, it's a 7-mark question. That's why a lot of work. I'm going to integrate the last one now. So when I integrate the last one, k over 4. K is 1 over 6. So 1 over 24. 10 becomes 10x. X becomes x square over 2 plus c. The upper limit is 10. So I'm going to sub in f of 10 is 1. So 1 is equal to 1 over 24 times 10 times 10 minus 10 square over 2 plus c. Get the value of c. That's all. So 1 over 24 times 100 minus 100 over 2. So c is going to be 1 minus this value. So 1 minus, the answer is minus 13 over 12. So f of x is 1 over 24, 10x minus x square over 2 minus 13 over 12. Now we have to write f of x using all the f of x we have calculated so far. Okay, we are going to take one by one. The first one was this. 1 over 12 x square by 2 minus x. 1 over 12 x square over 2 minus x plus 1 over 24 plus 1 over 24. And then the second one is kx. Now don't put kx. We know the value of k is 1 over 6. So it's x over 6. X over 6 minus 1 over 3. And the third one is this. 1 over 24 times 10x minus x square over 2 minus 13 over 12. Write the same limits as f of x. 1 to 3, 3 to 6. 1 to 3, 3 to 6, 6 to 10. And then 1 x is greater than 10, 0 x is less than 1. You put this curly bracket covering everything. That's our f of x. Whopping 7-mark question. So now if you look at the marking scheme, this number is going to be slightly different because they have taken out the common factor and all, but do not worry about it. You don't need to do that. You can just write it this way. You'll be given full marks. Let's move on to the last part, part D first. Given that E of x is 61 over 12, find P of x greater than E of x. Greater than 61 over 12. We can write it as 1 minus p of x is less than or equal to 61 over 12. That's basically cumulative, right? F of 61 over 12. So what is 61 over 12? What's the value of this? 5 point something. So in capital F of x, 5 point something is here. So to find the value, you need to sub in 5 point something, that whatever value given here in this, and calculate it. Okay, x over 6 minus 1 over 3. So I'm going to put it as x over 6 minus 1 over 3. Get this value. 1 minus 61 over 12 times 6, minus into minus plus 1 over 3. 0.4861 dot dot dot, round it to 3 significant figure. That's all. Part E, describe the skewness now. Okay, for skewness, I'm gonna show you. Okay, for skewness, look at this figure. These are all the conditions for positive skewness. You can take note of this figure. If you see the opposite way, that's negative skewness. So if median is smaller than mean, that's positive skewness. In this case, we know median is 0.5. Mean E of x is 61 over 12. 61 over 12, which is 5 point something. So median is less than the mean, therefore it's positive skew. That's all.